So the classical second derivative test, as we commented, tells us a little bit about what the function is doing. And there are three possible cases then. We have to check the second derivative, and the second derivative could be positive, in which case our function is curving upwards. When the second derivative is positive, we know that we have a local minimum. When the second derivative is negative, the function is curving downwards, and we know that we have a local maximum. And when the second derivative is 0, we don't have enough information to draw what the graph of it looks like, because it could be doing just a very hard turn where more derivatives vanish than just one, or it could be doing something like this where it flattens out and then does movement in different directions. We can't tell just from the second derivative test. And so this one is a minimum, and this one is a maximum, and this one is a failure of the second derivative test. In our case, there's actually going to be 4 different versions because several variables are slightly more complicated than 3. We could have the easy cases where we have definitely a local max or definitely a local min. But there's also a third one where we do have some definitiveness. It's definitely a saddle point where it's neither a maximum nor a minimum. In some directions, the function goes up, definitely, and in some directions, the function definitely goes down. Or we could have complete failure of the second derivative test where it does not tell us enough information to know if we have a local max or a local min. And figuring out exactly how to separate those out is what we need to do. The way that it works is the following. At a critical point, the critical point means that the first derivatives all vanish. And so our quadratic approximation, the second Taylor approximation, says that f of x is pretty close to its value plus this 1/2 of x minus a transpose times the Hessian times x minus a. And we need to check, is this possibly bigger than f of a or smaller than f of a? If it can't be bigger than f of a, then we have a local max. And if it can't be smaller than f of a, we have a local min. And that's equivalent to the question, is it possible that this contribution on the right-hand side, something transposed times the Hessian times something, could that ever be positive or negative? Could it be both? Is it always going to be 0? What happens? And so here's how the second derivative test works. What we do is we take the Hessian matrix. We have to calculate the Hessian matrix at our critical point. And then we step through this matrix one by one, and we draw little squares, and we calculate their determinants. So we calculate the determinant of the little 1 by 1 matrix in the corner, then the determinant of the little 2 by 2 matrix, and then if we're in 3 dimensions or higher, we calculate the determinant of the little 3 by 3 corner, and we do all of those. And we check which of those determinants are positive, which are negative, and which are 0. Then there are 2 cases that are easier to check. One of them is if those determinants are all positive, it's a local minimum. Same way as single variable. People expect the other case to be different than it is if the determinants start negative and then they alternate signs. They go negative, positive, negative, positive, negative, positive. Then it's a local maximum. The first one has to be a negative. So positive, negative is no good. If they start negative and then they alternate in signs, that tells us we've definitely got a local maximum. Those are the 2 most straightforward cases. The hard cases are distinguishing between saddle points and failure of the test. So failure is if the determinants are all 0, or if they're all positive and then they're all 0, or if they start negative and alternate and then they're all 0, then the test fails. One way to think about this is like normally having 3 positives in a row would tell us that the second derivative test worked and we had a local minimum. But the second derivative test fails if it looked like we were on track to get a definite answer, but then we fell off a cliff and eventually just had a bunch of zeros. So if we get positive, positive, 0, or if we get positive, 0, 0, or if we get negative, 0, 0, all 3 of those could legitimately have been an answer to the second derivative test, except that eventually we started getting zeros. that's when the test fails and we don't know whether it's a local max or a local min. But if we get anything else, if we get, positive and then a 0 and then a positive, that's not this list. It didn't fall off a cliff. It started and then we got a 0 and then we got something else. Then it is definitely not a local max or a local min. It's some kind of saddle point that may have complicated behavior, but it's definitely not a local max or a local min.